Okay, dear students, now let's see how we can find the upper and lower bounds of questions which are given in terms of intervals. But before we go to how we can find upper and lower bounds of a set of real numbers given in an interval, we have to know what upper and lower bounds are. So in a given set of interval of real numbers, a number is said to be an upper bound, and if it is obtained to be the greatest of all the numbers within the interval, and it is said to be a lower bound if it is the least of all the numbers available within the interval. Okay, so having this into account, you are asked here now to find set of upper bounds and lower bounds for the given interval. So here it is from -3 to 5. So how can we find the upper bound and lower bound of this one? Simple. So clearly the solution goes like this. The set of possible upper bounds is the set containing real numbers greater than or equal to 5. Because as you see, look here students, whatever number you may take, see 5 and above it, they all are greater than or equal to these values. Okay, equivalentness is considered, don't forget please. You see, whatever number you may take within this set, you see, the number is obtained to be the greatest of all the entries within this interval. So you see, some upper bounds are, you see, for example, you may take 6, 10, 100, 1000, even 5. You see, all these can be possible what upper bounds. So a set containing all possible upper bounds for this particular interval is this one. How about the set of possible lower bound? The set of possible lower bounds is the set containing what? Any real number less than or equal to -3. Because this, if you take a number within this set, you see this number is going to be the least of all, you see, the values within this interval. For example, you may take -5. Everyone agrees that -5 is within this interval because -5 is less than or equal to -3. So clearly -5 is less than or equal to every within this interval. What about if I take -3? Again, -3 can also be because -3 is less than or equal to every entry within this interval. So whatever, you see, number you may take, as long as it is less than or equal to -3, it can be considered as a lower bound. You see, so the possible sets are as you see here. Let's proceed to the second type of interval. This is basically half open and half closed. The first one was both closed interval. But now again, when you come to this, nothing special is to be considered. The set of, you see, possible upper bound is the set containing, you see, any real number greater than or equal to 10. And the set of possible lower bound is nothing but it is the set less than or equal to, you see, the set of real numbers less than or equal to 2. So clearly, even though, look here, student, 2 is not included here, it's clear that, you see, 2.000 something like that is considered here. So a number which is, you see, greater, which is less than, you see, this is going to be considered to be less than or equal to 2. So look, whatever number you may take less than or equal to 2, it is supposed to be the least of all the entries within this interval. So this is a set of possible lower bounds. What if we take another interval like this, you see, which is basically half closed and half open? Nothing is, you see, going to be new for you because, you see, what you did can be applied again for these two. The set of possible upper bound is, you see, any real number greater than or equal to 9. You see, so whatever number you may take, as long as it is greater than or equal to 9, it can be, you see, the greatest of all entries within this interval. And the set of possible lower bound is the set containing less than or equal to containing any real number less than or equal to 4. You see, so every number within an element of this set can be, you see, the smallest of all the values within this interval. So the set of possible lower bound is the set containing any real number less than or equal to 4. And the last type of interval is the interval where we have both opened, as you see. So this interval, as it has been stated here, is nothing but it is a collection of real numbers within the interval within 5 and 8. 5 and 8 are excluded, but in the case of this, 4 is included, 9 is excluded. And here 2 is included, 10 is included, 2 is excluded, sorry, and 10 is included. In the case of these two, both are included. You see, so when we write this, we mean any real number between -3 and 5 inclusive of the 2. In the case of this, any real number exclusive of 2 but inclusive of 10. So this bracket stands for inclusiveness, whereas this one standing for, you see, exclusiveness. So any real number greater than or equal to 4 but less than 9 is considered in the case of this. So, in the case of this, now what are the possible upper and lower bounds? Clearly, the set of possible upper bound is going to be any real number greater than or equal to 8. Whatever number you may take within this interval, it is automatically the greatest of all the entries within this interval. What about the set of possible lower bounds? When you come to the set of possible lower bounds, this would be a set containing any number less than or equal to 5. So clearly, dear students, what do you understand from this? From this, one can easily understand that whenever you are asked to find a C upper and lower bounds, please try to consider the extreme values. For example, in the case of this, -3 and 5, look, 5 is considered to be, you see, is the entry, as you see here. So any value greater than or equal to 5 is the upper bound, and any value less than or equal to -3 is a lower bound. So -3 is directly taken from the lower value, from the smaller value here, and 5 is directly taken from the greater one within the interval. So whatever extreme numbers are given to you, don't worry about the intervals appearing here, I mean the type of the intervals appearing here. You see, just take, you see, the first values, -3, 2, 4, 5 as extreme values for, you see, the lower bounds, and the second numbers like 5, 10, 9, and 8 as extreme values for the upper bounds. In such a way, we can simply identify possible set for, you see, lower and upper bounds. Having this into account, what comes next is the 15th question, and that says find the least upper bound LUB and the greatest lower bound GLB of the above. So as usual, before I continue doing this, I would like to define what least upper bound and the greatest lower bound are. The least upper bound of, you see, a certain interval of numbers is nothing but it is, you see, the list of all the possible upper bounds we listed. And here the name applies to you in the case of the second one, you see, it is the greatest of all the lower bounds that we call GLB, okay? So in such a way, we are going to identify this least upper bound and the greatest lower bound. So when you come to, you see, the first one, you see, in the case of the first one, look, all possible upper bounds are written here. Any value greater than or equal to 5 can be an upper bound. It could be 5, 6, 10, 1,000, million, like that. So from this, you see, mentioned numbers, for instance, the smallest value is 5. So the least upper bound is considered to be number 5. And here again, you see, we have, you see, the greatest lower bound to be -3, because you do have a lot of lower bounds. For instance, you may take -4, -6, -10, whatever numbers I just mentioned, as long as less than or equal to -3 can be lower bound, and the greatest of all this is -3. So GLB is -3. Same analysis can be done for the next one. You see, you do have actually a lot of numbers greater than 10, greater than or equal to 10 as your upper bound, but the least upper bound will be 10. Here also, the greatest lower bound will be 2 by applying similar procedure. Look here, students, 5 is directly taken from the first one, -3, look, second, 10 directly taken from here, 2 directly taken from this one. Similarly, I hope you can do the rest. Here are, you see, the rest values. LUB for the third one is 9, GLB 4. And for the fourth, the least upper bound is 8 and the greatest lower bound is 5. You just need to apply same concept as I applied for the first two. Up next is another question, and here you are supposed to write true if the following statement is correct and false if it is incorrect. So let's see the questions now. The first is the sum of any two rational numbers is rational. What can you say about this, dear students? Take an arbitrary two rational numbers. Do you think that the sum is again irrational? I hope you are saying yes. The answer is true. The reason is, the set of rational numbers is closed under the operations of addition, subtraction, and multiplication. Even though it's not closed under the operations of the operation of division, it is closed under these three operations: addition, subtraction, and multiplication. Due to this fact, the sum of any two rational number is irrational too. Coming to the next one, the sum of any two irrational number is irrational. Guess what is going to happen? What's going to come? I hope you have answered saying false. Right, you are. This is false. The reason behind this is, for instance, take arbitrary two irrational numbers. We knew that radical 2 and minus radical 2 are two irrational numbers. You see, these two are irrational numbers. We are unable to write these two as over before. What will happen if we take the sum? If we take the sum of these two, it will be 0. So it is not true always that the sum of any two irrational numbers to be irrational. Sometimes you may obtain rational, as you see. Now coming to the third one, the product of any two rational numbers is irrational. What can you say about these, students? So as you clearly known, the answer is true. Look, take arbitrary two rational numbers. The product is going to be again a rational number. The idea is similar to the one I explained in A. The set of rational number is closed under the operation of multiplication. Coming to D, the product of any two rational number is irrational. Do you agree with this, students? I hope your answer is what? False. So let's take now a counterexample how we say this to be false. For instance, take radical 2 and radical 8. Students, these two are irrational numbers, as you know, because we are unable to take them out from this radical. But even though they are irrational numbers, if you multiply the two, you will get a radical 16, which actually is 4, you see? And we know that 4 is a rational one. So, whatever, you see, two irrational numbers you may take, we will never obtain, you see, irrational always. There is a case where we can have a rational number, as you see here. And coming to the next one, it says the sum of a rational and irrational number is irrational. What can you say about this, students? Do you agree with this? I hope your answer is going to be true, because whatever a rational and irrational number you may take, if you take the sum or the difference, it's going to be always irrational. Let me just try to clarify this one by using the concept of contradiction. Suppose you have a to be a rational number. Consider a to be rational and b to be irrational. Now, assume that the sum of the two is rational. Basically, it was irrational, but now let's consider it as if it is rational. So our assumption here contradicts with the other basic thing. Because of this, we can come back and say that the sum is irrational through recreation. So, look, if a plus b is rational, b is going to be, look, just bring a to the right, rational minus rational, because a is rational. So, b is going to be the difference of two rational numbers. Sorry, student. Rational numbers which contradict that b is irrational. Hence, the sum is irrational number. What about if, student? Do you think that the product of a rational and irrational number is irrational? Yes, the answer is false. Let's take possible values. For instance, take 0 and radical 2. 0 is what, student? Rational number. And radical 2 is irrational. So the product of the two, 0 and radical 2, makes 0, which actually is irrational one. It is because of this that we say it is false.